is load path. So if you look at this problem, now what is the self weight? Let's say you are having slab thickness as 0.12 meters. Okay. Brick wall thickness, let's say 0.15 meter. Okay. Then say length of this panel is 4 meters, and this is say 6 meters. Can you calculate the weight of slab? How can we calculate the total weight is one term, and then second term is the per meter square weight, per meter weight, like that. Okay. So what is the total weight of slab? You know, density into, let's say density into volume. Density is 25 for concrete. Let's say it is a concrete. And volume is 0.12 into 6 into 4. Okay. So this will come some number. Let's say 72 kilonewtons. This is the total weight of the slab. Now, where this load will go? Total load, बताओ कहाँ जाएगा?
Sir, wall fill.
So it will go on two walls. There are only two walls which are taking the load. So the slab will transfer the load up 50% here and 50% here. So if this is 72 kilonewton, then 36 kilonewton will go on this wall, 36 kilonewton will go on this wall. Okay, simple. But this is total load. So generally, whenever we calculate the loads on structures, now this wall length is 4 meter actually. So if I ask you how much load is going on wall per meter length, अभी ये total 4 meter में जा रहा है 36, तो per meter कितना जाएगा wall पे?
36 divided by 4, sir.
Yes, so load on wall per meter is equal to 36 kilonewton upon 4, which is 9 kilonewton per meter. So this we call it as a UDL, uniformly distributed load, or uniform force, UDL. So you should understand the term. Load is total load, and UDL means uniformly distributed load, either per meter, or if the slab is there, we can call it as a per square meter. Now I ask you, what is the load of the slab per square meter? Whenever I say per square meter, that means if I assume slab length 1 meter here, 1 meter here, and thickness 0.12, तो per square meter slab का load कितना है बताओ? Slab load per meter square. अभी total load कितना है slab का? 72 kilonewton per square meter. If I ask you, yes.
Sir, 72 divided by slab area.
4 into 6, 3 kilonewton per meter square. Okay. Now, as generally in structural engineering, we are dealing with per square meter loads, means 1 by 1 meter panel. So this is one method. You will calculate the total load and will divide by the area. Second method is, can you calculate slab load per square meter by any other method? Slab load is equal to thickness into density. Okay, directly we can calculate. So what is the thickness of the slab? 0.12 meters into density is 25. So this comes out to be 3 kilonewton per meter square. समझ में आ रहा है सभी को? So if you want load in per square meter, just multiply with the thickness. That's it. Okay, for slabs. Now if I ask you how to calculate the self weight of the wall, क्या आएगा बताओ? Self weight of wall. So If I ask you total weight कितना आएगा? Density into volume. So density of brick wall is 20 kilonewton per meter cube. Volume of brick कितना है अभी? ये thickness into let's assume height as 3 meters लेते हैं चलो. Okay. 3 meter is the height of the wall and length of the wall is 4 meters. Height into length 36 kilonewton, right? This is total weight of the wall, but if I ask you to calculate the weight of the wall per meter length, कितना आएगा? So we have already calculated here. 36 divided by 4, that is 9 kilonewton per meter, UDL if I say. Is there any other method to calculate the load on wall per meter? Batao. So load on wall per meter.
Sir, height into wall thickness into density.
Yes, so 0.15 into height. And length is 1 meter. So we are not bothered. That is 1 there into density. This comes out to be 9 kilonewton per meter. Okay. So thickness into height into density. So this kind of methods we generally used whenever we do the calculation. For calculation of slab load, thickness into density. For calculation of wall loads, thickness into height into density. Okay. So this is the general methodology. Now, if I ask you how much load from slab on the wall will transfer per meter. Load on wall from slab per meter length of the wall. Six. No. Tell me the methodology. Methodology is important.
0.12 into 25 into 4 divided by 2.
Yes, so load on wall from slab is equal to, so you should know the slab load. Slab load कितना है हमारा? 3 kilonewton per meter square. Okay. अभी ये हमने यहाँ निकाला था 36 divided by 4, that is 9 kilonewton per meter. But so you can use per meter square load. Okay. अभी आधा जा रहा है यहाँ. Half is going to this side. This half blue color load is going on this wall and this orange color wall load is going on. That means half means what? What is the span of this slab? Half span. कितना है बताओ? ये कितना है? अभी हमारा ये 6 मीटर है ना? This is your 6 मीटर. So half means 3 meters. 3 meter width will go on this wall, left side wall, and 3 meter will go on the right side wall. So you can transfer the load as it is a one-way loading. You do you know this is one-way loading because there are only 2 walls which will take the load. So half load. So 3 kilonewton per square meter into what is half? 3 meters. How much is it is coming? 9 kilonewton.
6 3
6 meter है total. So half मतलब 3. So 9 kilonewton per meter. So see, you can understand by looking at this. So either you can calculate the total load and then transfer it. And if you want per meter, divide by the length. Or direct method is you use the slab load per square meter and multiply with the contributory width. This is called as contributory width. How much load it is giving? कितना load ले रहा है वो? कितना portion का slab left side को जा रहा है? So we can say generally in structural engineering, we are dealing with the slab loads. So slab loads are, if you want to calculate slab load, use thickness into density. So you will get the load in kilonewton per square meter. If you want to calculate the wall loads, thickness into height into density. Okay, and the unit will be kilonewton per what? Meter per meter, UDL. This is UDL. This is also UDL, but UDL per square meter. See, so the units are very much important whenever you calculate the loads. If you miss any, this meter square becomes meter or meter becomes meter cube, then it will change the meaning of the concept. Okay. So this is the overall idea regarding the load calculations. And how much load will go on the footing? Footing पे कितना load जाएगा बताओ? Now
slab load and mod load.
स्लैब का टोटल लोड कितना है? अभी टोटल लोड के कंसेप्ट में देखेंगे. स्लैब का टोटल लोड है 72. ओके, जिसमें का 30 कितना निकाला था हमने? $36 kilonewton इज फ्रॉम द स्लैब. और इसका कितना है? It's not 36, it is 27, right? You can see from here. We will calculate here itself. Okay, then slab load is thickness into density. So how much it is coming out to be? 0.12 into 25. This is 3 kilonewton per meter square. So in which 3 kilonewton into that 3 meter, that is the 9 kilonewton per meter. So 9 kilonewton per meter is the load coming on one wall into height. Length of the wall is 4 meters. So it is 36 kilonewton from slab. और wall का weight कितना है? 0.15 into height is 3 into density. This is 9 kilonewton per meter. So it is again same 9 kilonewton per. Luckily it is coming same into 4 meters the length, 36. So 36 from slab, 36 from wall. Total 72 kilonewton will go on one footing. So on footing, what kind of load we transfer? Generally on footing, क्या footing का load कैसे transfer करते हैं? Per square meter. So we generally calculate the pressure on the footing. Okay. So what is the pressure on the footing due to this? Total load 72 kilonewton into area of the footing. So you can assume any size. Let's say this is 1 meter width of the footing and length is समझो 5 meter. So length of the footing is, let's say, 5 meters. I'm just assuming some numbers. So area of footing will be 72 into 1 meter into 5 meters. Write down the units if you are beginner, and kilonewton per meter square. So this is the load on footing. That is the pressure on footing, we can say. So this is the overall load path. So slab will have its weight. It will transfer half load on the wall, half load on this wall. Then self weight of the wall is also there. So total slab load plus wall load will transfer on the footing. Now don't forget that footing is also having self weight. So footing, if you assume, let's say footing thickness is 0.5 meters, thickness of the footing. You can calculate the weight of the footing also. Weight of footing is what?
62.
1 meter into 5 meters into thickness is 0.5 meters. So this is your volume into concrete. Concrete footing है इसकी वजह से. कितना आएगा ये?
62.5 kilonewton.
62.5 kilonewton. This is the total load. And this is per square meter. No, this is total load. Now, this was the pressure on footing from slab and wall. अभी footing का load कहाँ जाने वाला है? Total load will go where? यहाँ क्या है नीचे? Below the footing, what is there?
On site.
Soil. So soil will have the load of footing, load of wall, load of slab. Everything will go directly on the. So if you want to total load going on the soil, so on soil, total load kitna ja raha hai? 72 from the wall and slab plus self weight of the footing is 62. Let me write round figure. So this total load will go on the soil, but how much area? So what is the pressure on soil?
400.
Load upon area. So why the size of the footing will be the, so 1 meter into 5 meters. Kilonewton per square meter. So you know that this pressure on soil, we generally compare this with the soil bearing capacity. I think all of you know it should be less than the soil bearing capacity. Then and then your foundation is safe. Okay. So this is the overall concept about the load calculations. Now, once you calculate the load, I will tell you how to draw the loading diagram, because loading diagram is very much important for calculations and analysis. So let me summarize. As there are two walls, there is a one-way load only. So if you see the load direction, it is one way. Whenever I say the load is one way, that means there is only wall here and wall here. अगर दो चारों side wall रहते तो कहाँ load जाता बताओ? Where the load will go if there are 4 walls?
It's one way.
So it will be shared by 4 walls. अभी share 2 कर रहा है इसलिए 50% is here, 50% is here. And then in that case there will be 25% on this wall, 25% on this wall. Now currently we are dealing with only one-way slab. So this we call it as a one-way slab. So one-way slab we are only dealing with this 50% means अभी ये हमारा कितना है span 6 meter है ना ये. This is my 6 meter. So 50% means I can say this is 6 by 2. 6 by 2. On this wall 1 and wall 2, it will be 6 by 2. Contributory width. Okay, now let's draw the loading diagram. So how, if I show you the loading diagram, so let me draw the frame. So all of you know that whenever we do any analysis, we generally draw the single line diagrams. And load can be shown like this. Let's say this is your slab. So load can be shown like this, or it can be shown like this also. Okay. ऐसे भी load दिखाते हैं. Now this is your slab, this is your wall. Now let's calculate the load per meter wall length, per meter slab width. ये जो है ना, ये ऐसे assume करूंगा मैं. Say this is 1 meter only. And this span is how much? 4 meter है ना हमारा? No, 6 meters. Span of the slab is 6 meter. Now if I can split this loading diagram in parts. So if I want to draw the loading diagram of the slab, it should look like this. And ये वो load है समझो. 6 meters. Now tell me what is the load of the slab here? W is nothing but, you know, that thickness into density. Thickness is 0.12 for the slab, density is 25. So the load is 3 kilonewton per meter square. Okay. As we are doing for 1 meter, you can say it is per meter now. If it is for 1 meter only, right? Now, what is this arrow? What is the meaning of this arrow? This I'm only drawing the slab. Slab ka loading diagram hai ye sirf. I'm splitting that. What is that arrow indicates? This is, we can say, reaction. But who is giving the reaction to this slab? कौन react कर रहा है उसको? Wall है ना? So let me say this is W1. So reaction on W1 and W2. Let's say this is W1 wall, this is W2 wall. So if I draw the loading diagram of wall, so ये समझो मेरा vertical wall है, ये मेरा vertical wall है. So whatever this reaction is coming here, this arrow, this will go on the wall. ऐसे downward जाएगा ना? Let me say this is R1 reaction 1, R2 reaction 2. So ये R1 इस पे जाएगा ना wall पे बाद में. And this R1. Now let's calculate the loading. So कितना ये 3 kilonewton per आए. तो what is the reaction? बताओ ये reaction कितना आएगा ये? Slab का reaction कितना है?
Sir, W by 2.
WL by 2.
1.5.
So 3 into L is 6 divided by 2. कितना है? 9 kilonewton.
9.
R2 भी 9 kilonewton आया. That means ये R1 9 kilonewton. Now this is per meter. Don't forget. ये 1 मीटर के लिए निकल रही है इसलिए चल रही है. Or you can write here also like this. So this R2. Now if you want to calculate, अभी यहाँ कितना लोड जाएगा बताओ. अभी यहाँ फुटिंग है मेरा. यहाँ फुटिंग पे लोड कितना आएगा बताओ. फुटिंग में ये सेल्फ वेट भी ऐड होगा ना वॉल का. यस. सो सेल्फ वेट ऑफ वॉल मतलब थिकनेस इनटू हाइट 3 meters इनटू डेंसिटी 9 kilonewton. So now tell me what is the load on the footing? Nine from slab and this self weight 9, 18 kilonewton, right? Per meter चल रहा है अब हमारा इसलिए. I'm just using this 1 meter length of the wall for calculations. And if I multiply with the total length of the wall, then it will be total load. So this is 18 kilonewton per meter. Similarly, it will be 18 kilonewton per meter. And if I ask you to draw the loading diagram for the soil, अगर ये soil है समझो ऐसे. अभी soil पे load कितना जाएगा बताओ. Soil. So ये self weight of footing. So footing का self weight क्या आएगा? Per meter निकाल रहे हैं हम. Thickness 0.5 है हमारा footing thickness. Then ये width कितना है? कितना था? कितना assume किया मैंने? 1 meter ना? ये 1 meter है. Width of the footing. 1 meter into density of footing into 1 meter length है इसलिए मैं नहीं ले रहा हूँ बाकी volume नहीं ले रहा हूँ. Okay, so it is how much? So here it will be 18 plus 12.5, which is 20.5 kilonewton on the soil. So this is called as the load path. Slab to wall, wall to footing, and footing to the soil. So this is the overall load path. Generally in RCC structure or any structures, the load transfers from slab to the beams. If there are beams, it will transfer to the beam. If there are walls, it will transfer to the walls. Then it will transfer to the columns. Okay, columns or walls. Then it will transfer to the footing. And from the footing, it will transfer to the soil. This is called as a load path. Okay, this total terminology means load path. This is for gravity condition. We are talking gravity loads only. Okay, so I hope you got how to calculate the loads and general load path for this small problem. All of you got this?
Sir, that addition should be 18 plus 12.5, na?
18 to 30 ना 30 आएगा नहीं
30.5, na, sir?
30.5. This will be 30.5. Now this is the overall idea regarding this. Now